Hello MUS 1002 students! In this video, I am going to give you a very brief overview of recording and how it works. So, once upon a time, recording was a specialist technique and domain, but now anybody can get started recording audio using a smartphone, a tablet, a laptop. But studios are still a very special space that deserves some consideration and going over it. Studios are designed to avoid parallel surfaces in what's called the main or the live room. This is because that keeps sound waves from bouncing back and hitting the microphone from the opposite side, creating phasing problems. The live room is designed to have a natural reverb, but also to allow isolation of different musicians within the room. Additional isolation is provided in smaller ISO booths, which use sound-absorbing material to prevent sound from bleeding in or out of the booth. These are very similar to a specially designed drum room that isolates the drummer's sound, adds a little bit of natural reverb, but most importantly, allows for the microphones and the drum kit to be permanently set up and left in position. It can take hours to properly set up and test the mics for a drum kit. It is truly best practice to leave them in position if you have a drum room. Here's a floor diagram. You can see the main room has no parallel surfaces. It has multiple ISO rooms, 1, 2, 3, and 4, with number 1 being the most likely candidate for the drums. The control room is where the recording engineer would sit with the console and the audio interface and the computer. They're able to see through to the studio and into all of the ISO rooms, and they have a direct door to go to the studio if they need to make any adjustments. Within the studio, it's really important to keep cables managed and tripping hazards down to a minimum so that you don't accidentally faceplant and destroy an expensive guitar or microphone. So to do that, snakes or bundles of cables attached to a small patch bay or panel of termination points allow for easy connections of microphones from the main room to the control room where the console interface and studio monitors and computer reside. This also has the benefit that using snakes and cabling like that will sonically isolate the main room from the control room so that the engineer can hear everything on the studio monitors without it bleeding onto the recording and potentially causing feedback. When they're recording, the musicians will be wearing headphones to listen to each other, to previously recorded tracks, and to any instructions from the engineer in the control room. I will note that these will always be wired headphones. You will never use Bluetooth headphones for this purpose, because Bluetooth introduces a slight but noticeable delay. They are not suitable for professional recording use. Talkback mics will also be set up for the musicians to use to communicate to the control room. These are mics that go directly into the console and are routed in there so that the engineer can hear the musicians talking, but that are not routed to the computer and thus are not recorded. And as impressive as a live studio is, it's now possible to actually build a home studio pretty easily and cheaply if you have an extra room in your house. You can get sound absorption panels on Amazon or Sweetwater. Cables can easily be run from one room to another under doors to isolate performers. And the recording process itself will be pretty much identical in all respects with one major exception. When you're recording in the home, and especially if you're in the same room as the musicians, the recording engineer will have to wear headphones while monitoring the recording process to prevent feedback from speakers. Feedback, also called the Larsen effect, is noise accumulation from an instrument or microphone and a speaker, where the noise coming from the speaker is then picked up again by that same microphone or instrument pickup and constantly accumulates. It results in that really loud squealing sound. And it's particularly pronounced when using the microphone and speakers on a laptop computer, and as a result should be avoided at all costs. If you're trying to record on a laptop, you gotta use headphones. So for the recording process, it always starts with pre-planning. The engineer or their assistant will research the band to figure out what their style of music is. Generally, the bands will give them some demos so they can listen to that, how many musicians are in the band, and what they'll be playing, what equipment will be used in terms of instruments the band is bringing that the recording engineer already has in their studio, what mics will be used. And then there's the all-important question of if the session will be recorded with everyone at once in the same room or in isolation. All of this information will be recorded on an input list and a room plot, laying out where each musician is positioned, what mic and headphones they will use, where the talkback mics will be positioned, and any other initial details. However, from personal experience, I can tell you that updates to the layout will happen frequently, and so my preferred method of working with this is to do everything in pencil and take lots and lots of photos on my iPhone. And then have those printed out and put with the session notes, because everything is going to change. And if you need to go back, you need to know where everything was laid out. The actual recording is going to start with a decision by the band and the engineer on whether to use a scratch track or a click track. A scratch track is a recording of the song as played by the whole band that serves as a playback guide to recording other parts in isolation. A click track is a predefined metronome part that uses a tempo map based on the song's meter to let each musician hear the pulse from a metronome and stay in sync. Sometimes everyone will hear the click track, sometimes only the drummer will hear it, and will monitor the click track on headphones, while other performers will play and record to the drum track, either in the same room or in isolation. So click tracks make it really easy to keep everything synced and to edit things, especially in a program like Pro Tools or Reaper. But they can feel robotic and dead. You can't swing as much, and there's no speed up or speeding down naturally where the song would want to do so. So playing and recording to a scratch track lets the band adjust the tempo of the song, make those speed up, slow down changes as needed, which generally results in a more natural sounding performance. Once the decision has been made for click or scratch tracks, the engineer and the assistants will set the levels for all of the microphones. Phantom power will be applied as needed, and one by one, the engineer will bring up the volume faders of the mixer to unity, which is plus or minus 0 dB. Essentially, what you are hearing is what is getting recorded. Then they will increase the input gain, which is the loudness of the input going into the mixer or the audio interface for each microphone, until every instrument can be heard, but so that they're not clipping. Clipping is when you are recording the signal too hot and it overloads the volume of the recording device, causing distortion. And it should be avoided at all costs when recording, because once it's recorded, there's no getting rid of it. You have to re-record it. If you notice it, you need to reduce the input gain of the microphone on the channel that is causing the clipping. Finally, while it won't affect the recording, the engineer will frequently pan the tracks and position them in space from left to right based on where the performers are standing. This is really, really helpful for the musicians because then they can hear the parts in the headphones as they're laid out in the live room itself. Now, panning is also essential in mixing music because we have ears on both sides of our heads. And there's a slight difference between when a sound hits one ear and then the other. And that helps us to locate a sound in space. If we hear more over on the left and then a slight delay on the right, we perceive the sound as being more on the left. If we hear more on the right and then a slight delay and then we hear it on the left, we think it's more on the right. Additionally, leaving everything straight in the center without any panning creates a mono mix, which typically results in really big problems of instruments or parts hiding behind other parts. You might hear the bass drum, but you might not hear the bass guitar, for example. So panning is used to separate everything out, put it into its own place, and allow the parts to come through. At this point, the recording starts. If it's going to use a scratch track, everyone will be recording at once, and then individual parts will be re-recorded in isolation. If it's a click, you can do either individual parts and build the song up part by part, or you can record the entire group. So the benefit of recording the entire group is that the performance will be similar to how the band has practiced and performed on stage. They're going to be more comfortable with it. But the benefit of recording individual parts is that it minimizes bleed. In either case, there will be some mistakes that happen during the recording process. And if that happens, you just keep going. You drop a marker in the session where the mistake occurred and put that in the session notes. Then you can go back after they've finished the take and you can re-record that part using what's called punch in and punch out recordings, or by doing multiple takes. Punching in is a technique used in digital audio workstations where you tell the software to start recording at a set point. When it hits that point, it starts recording, and then when it hits the punch out point, it stops. And generally, you can give them a little bit of what's called pre and post roll, which allows them just a couple extra seconds on either side so that the band can get into place and feel what they've already recorded and get in sync with their previous take. And then you can just record that very small portion, and then you have a little bit extra wiggle room on either side when you're doing the splicing. In fact, most music is recorded by doing lots of individual punch-ins or by recording a number of takes. Takes are individual recordings of the same segment. So maybe you do 5 takes of the same verse. These are then arranged in a playlist and compiled or comped together by the engineer, saying, I'm going to take best part of take 1, this first line of the verse. Then I'm going to take the first half of the second line from take 3, the second half from take 2. All of the third line is going to come from take 4, and then the rest is going to be take 5. You select those parts, and then you use those to create a composite take using those best parts. It's extremely common. I guarantee you that if you have heard music since about 2000, you have heard thousands of comp takes without even knowing it. When you're recording individual parts on top of a scratch track, it's really common to start with the drums, then work through the rhythm section. So that would be drums, bass, rhythm guitar, any auxiliary percussion, any type of keyboard instruments that are not soloing, and any pre-recorded loops first. After the rhythm section is recorded, the process will differ a little bit based on the engineer and the band. Some will move on directly to vocals, while others will do the major instruments. So your solo guitar, your lead. But the instrumental solos are always recorded last, as they tend to require the largest number of takes and the most amount of time to work. When recording an entire band at once, the big issue is if a mistake has been made. If that's happened, the entire band will have to re-record the section, punching in and punching out as needed. I will say it's technically possible to comp multiple takes of a single instrument together, say to fix a mistake in just the guitar part, but bleed from recording the entire band on the other tracks will make this extremely obvious. You'll hear the wrong note from the guitar in the bass part, for example. When recording everyone at once, again, solos are typically recorded separately. All of the non-soloists will record their part, and then the soloist can record their part later on so that they're not holding everybody up. People can go out and get coffee, they can go out and get lunch, or maybe the soloist wants 200 takes and everyone else can go to bed while the soloist and the engineer stay up and work on the solo note by note. Once these basics are recorded, overdubs are added. Common overdubs would be something like a second guitar part panned opposite the first, multiple takes of background vocals panned left through the center and then to the right in a small area, keyboard parts, or a second bass part panned away from the original. But solos and lead vocals are very, very rarely, if ever, overdubbed. The reason for that is that when you're recording overdubs, the purpose is to add small variations to the material in a song, and as a result, the performers will always be recording a second version of their previous take. But because everyone is human, there will always be slight differences between the original and the overdubbed, which can be accentuated by having them use different instruments. So switch out the Les Paul for a Fender. Change out the amp, even changing out the picks. And by having the parts sound slightly different, it makes the overall sound of the part bigger in the final mix, but it still sounds unique, and because of that, it can avoid technical issues like phasing in the mix in particular. Once the parts and overdubs are recorded, the engineer and the band will select the best takes and create a basic comp take. The final comp takes should be glued together in the software, and stems, or renders of each individual track with added silence on either side so that everything starts and ends at the same time, will be exported along with the entire project. The project and the stems are then given to the mixing engineer for the first part in post-production, and they will turn the final mix over to a mastering engineer to put the final touches on the project before it's ready for the public.